Hello there, welcome to my question of the day, and this is number 14 in a series I've been running every weekday on my Facebook page. So if you found me on YouTube, head on over to my Facebook page where they're all set out one by one. They're also on a playlist on here, so that's another way of finding all of the rest. Okay, so my question of today shows a regular pentagon and an equilateral triangle placed inside a square, and my job is to find the value of x. So I'm just going to highlight the word regular because the word regular means that I have got a pentagon whose sides are all the same and whose angles are all the same inside. I've also got an equilateral triangle, and most people know that the angles inside an equilateral triangle are all 60 degrees. But not as many people know what the angle inside a regular pentagon is. At the corner, I should say, most people don't know what the size of the interior angle of a regular pentagon is. Now, if you're one of those people, and you might not be, you might be very well aware what the interior angle is. But if you didn't know, what I would suggest is a really nice little way of doing this is you just choose one corner of the pentagon and you just start to draw diagonals to every other corner from that point. And if you do so, it splits it into 1, 2, 3 triangles. And if we have a look at all of the inside angles of all those triangles where each triangle's interior angles adds up to 180 degrees, we can say that the total of the interior angles of a pentagon, in fact of any pentagon, add up to 3 lots of 180 degrees. And with just a quick calculation, I can work out that that is 540 degrees. So that is going to help me figure out what each interior angle of my pentagon is. So all I need to do is divide 540 by 5, and I should get 108 degrees. So that might be quite useful information. So I think what I'm going to do now is I'm just going to put on all of the angles. I probably don't really need to because I could just colour them in pink really, but I'm going to anyway. Maybe I just like to make things more difficult for myself than necessary. Quite possibly. Right, the interior angles of my equilateral triangle are 60 degrees. Doesn't sit well with me without putting those little dashes on the sides to show they're all, in fact, those lengths of the pentagon are all going to be the same size as the lengths of the equilateral triangle as well. They have to be because they've got one adjoining length in common. Now, of course, in my square, I always have right angles in the corners. Now, I've got to work out angle x, so I'm trying to think about what angle I would need to work out on my diagram to help me. So I can see one angle right down the bottom left-hand side. It's going to be really hard for me to draw in. I've got this little tiny blue angle just inside there. If I knew what that angle was, I could add that blue angle there. Let's call it angle x. No, let's not call it angle x. I've already got an angle x. I don't want to call it angle x. I'd call it angle y. I would know that y add 60 degrees and x must make 180 degrees. So all I've got to do is find out that angle. Now I can see that if I outline this irregular quadrilateral right down at the bottom of the diagram, I know that the interior angles of any quadrilateral always sum to 360 degrees. So what I can do from there is I can find all of its interior angles, all the ones that I can possibly find. So I can work out that that top left angle in my irregular quadrilateral must be 72 degrees because, of course, those two angles added together must make 180 degrees because that's at a point on a straight line. I'm just taking a moment to check that. That does add up to 180 degrees. I'm very capable of making some poor mistakes sometimes. 1, 2, 3, 4, 5. Of course, I've actually got an irregular pentagon down there. Sorry. I'm just going to call that an irregular pentagon. I've just noticed it's got 5 sides when I stopped to count them. So its interior angles must sum, of course, to 540, as we know. I could work out that angle there. So I've got 108 degrees and 60 degrees, which makes 168 degrees. I can actually write as I'm talking. And then, of course, I've got angles around a point, which make 360. So I'm going to subtract 168 from 360. I get 192 there. Okay, so I can see that I've got 72 degrees, I've got a 90 degrees, I've got 192 degrees, I've got another 90 degrees, bottom right-hand corner, and I've got angle Y, which must add up to 540 degrees. Okay, so I'm just going to add 72, 90, 192, 90, and see what that comes to. So I've got 4, I've got 27, 34, and I've got 3 plus 1, which is 4, 444. So 444 plus Y is 540. I'm just going to do 540, subtract 444, the long way. It's easier when I'm talking. And I've got 96 degrees. So I know that Y is 96 degrees. So if I come back to the statement I made earlier, I now have, instead of Y at 60 at X, make 180 degrees, I've got 96 at 60 at X is 180 degrees. And I've got 96 and 60. Again, it's probably immediately obvious to you what that is, but when I'm writing and talking at the same time, my brain doesn't work brilliantly. 156, 66, 76, I think X must be 24 degrees. So if I have a look back to the question, I'm seriously hoping that that is one of the answers. And yes, it is. X is 24 degrees. Okay, thank you, and apologies for my slight errors in that question. Calling a pentagon, it's calling an irregular pentagon an irregular quadrilateral. Unforgivable. Anyway, I hope you did better than I did there. Thank you very much. I'll see you next time.